Okay, so here's the solution to my problem I posted in my last video. Let's take this pen over here. There's the center of mass of the pen C. A little offset from the center of mass, I have applied an impulse J. Let this distance be x. Now because of the impulse, the center of mass will acquire a velocity upwards. Vc, that will be equal to J by m. Also, since the impulse is a little offset from the center of mass, the rod will acquire an angular speed omega. Now how to find omega? So Jx, which is angular impulse, that will be equal to change in angular momentum of the rod. So that will be IC omega. Put in the value of J, m Vc times x will be equal to IC will be ml square by 12 multiplied by omega. So we obtain omega is equal to 12 Vcx by L square. Now let's draw the pen again. The center of mass has velocity Vc upwards. Also, about the center of mass, the pen is rotating with omega. So with respect to center of mass, this end over here will have speed L omega by 2 downwards. So with respect to ground, this, let's call this point as A. So velocity of A will be Vc minus L omega by 2 upwards. Okay, so we write this down. Vc minus L by 2 times omega. Omega is 12 Vcx by L square. So we write it down over here into 12 Vcx by L square. So we obtain Vc minus 6 Vcx by L. Okay. Now, if you remember the video, the first time I hit the pen, I hit it closer to the center. Okay. So this point moved upwards. And the second time I hit the pen, I hit it closer to one of the ends. So this end of the pen was actually going down. So here we have VA is positive and here we have VA is negative. So let's look over here. For VA to be positive, Vc minus 6 Vcx by L should be more than 0. Or we see that L should be more than 6x or x should be less than L by 6. So here we'll obtain the exactly opposite value, that is x should be more than L by 6 for this point to go downwards.